Windows 98 Virtual Memory Model. VMM is virtual memory. So the virtual memory provides more memory for applications than is physically available. So it gives you more memory than is really available in the machine. Well, where does the rest of the storage go? Out to the disk, right? Through paging. That's how it works. The OS moves data between the physical memory and the hard drive to free up space in physical memory. This is called paging when it does that. Older memory models used only the first 640 kilobytes of memory in the computer. This is really old, but yes, this is true. This was a big problem back in the day, big problem. You had to load virtual memory managers by hand. Now it's all done for you automatically. So when you see, in some memory models, you might see first 0 to 640 kilobytes, this is what they're driving at, right? So pun intended there with the drivers. So Windows 98 provides each application with its own virtual memory address space. So Windows 98 provides each application with its own virtual memory address space. So everything gets the memory, its own copy. And when we do a context switch, we switch from this application to this application. All the paging for this first application, so we have two applications, and we're swapping between the two. So we're running this one for a little bit, we're running this one for a little bit, we're running this one for a little bit, and we're running this one for a little bit. And to you, the user, you think I'm doing this switching for you, and you think that I'm doing it so fast, you think they're both running at the same time. It looks like they're both doing stuff at the same time. So, but each time we switch between one application and the other, we're taking this guy's application memory and we're writing it out to disk. And this guy, when we load him, we load his memory as well. So everything's loaded and swapped out that way. So we have a privilege mode, a system kernel mode, shared 98 core libraries, and dynamic link libraries. Dynamic link libraries are loaded dynamically, which means as something needs them, they're loaded into memory. Otherwise, they're never loaded into memory. So you might have 1,000 libraries on the computer and you only use one. And that's good because we don't have to load all of them in memory at the same time, just in case you call them. That's a lot of work, right? That for something you may never call. And then we have private Windows 32 based applications. We have the TSRs, the terminate and stay resident programs. And then we have real mode device drivers. They actually need to talk to that hardware. And see, that's where it goes in the 640K memory. Only our real mode device drivers. Everything else is virtualized and abstracted up into higher memory, okay? So that's the key here. Okay, virtual memory swap file system. So one other thing I want to say about this, I don't know if you're going to see it on this test, but it may help you derive some answers later or in this class or in further classes. When you load something in a computer, the first thing that loads is that 640 kilobytes of memory. That's managed first. And then, from then on, everything loads from the top down. Everything will start at 4 gigabytes and start working its way down. So in this list, which is the last loaded? The TSRs, right? Because we start with the 640 kilobyte, and then from then on we go top down. So it's privilege mode, system kernel mode. The first thing that comes up is the kernel. He does his thing. Then we start loading all this other stuff, right? Okay, so virtual memory swap file system. Windows 98 adjusts the size of the swap file as needed. The swap file is where it's doing the paging from. I'm taking all this stuff out of memory, putting in memory, I'm taking all this stuff out of the hard drive and putting it in memory because we just did a context switch. Now your time's up. I'm gonna load back this other guy. Now we swap back, okay? So the paging happens as the context switches occur. But those pages are only loaded from disk as they're needed though, okay? So it doesn't automatically load everything off the disk. It only loads what it needs to load. The processor will tell it, hey, so the processor has something called a look ahead. And it's looking ahead at the next couple of instructions and saying, I'm gonna need this memory, and this memory to do those instructions. You go get that. And then he's working on the stuff he's working on now. And then the memory manager goes out and starts loading those pages in memory and saying, hey guy, they're loaded, go ahead and run these instructions. So that's part of the pipeline, right? The pipeline to feed the processor. Because remember we talked about if the processor ever stops working, it'll reboot the system. So it's either executing no ops or it's loading, it's doing the look ahead and stuff like that. So we talked about the swap file. That's where all of the stuff that's in memory is loaded. So if I get a copy of your swap file, that's pretty good, juicy stuff if I'm a security guy, right? Or if I'm an attacker, actually. And then Windows 98 sets a swap file to 32-bit mode automatically. The memory pager moves pages to and from virtual memory. So virtual memory, we have a virtual memory manager, And then we have the pager, the memory pager, which actually manages the pages. And the look ahead from the CPU will tell the pager, well, tells the memory manager, and then that guy tells the pager what to load to and from memory. So they kind of figure it out together. It's a lot more complicated than that, but you could think of it, logically like that. That's how it happens. So Windows 98 creates an MS-DOS environment for legacy applications. So for like your old games and stuff, like Lode Runner that you loaded in DOS. And again, MS-DOS is Microsoft Disk Operating System.